Hello friends, in this video I am going to explain you how the insertion process is performed on a heap data structure. So heap is a data structure which we have for which we have given an overview in one of the earlier videos, but in this video I am going to give you an example to show you how insertion process takes place in a heap, how we can insert any node or any value in an existent heap data structure, and what are the necessary operations to be performed in that case. So let us consider a very simple heap, and I will just go on to insert one node to that heap data structure and show you how the process goes on. So the heap can be considered to be, I am just taking an example of a max heap. We could have taken a mean heap as well, but I am taking an example of a max heap in this definition. So the max heap can be taken to be like this: 95, this is 87, this is suppose this is 92, this is suppose 68, this is 78, this is 92, this is suppose 84, and this one is suppose 55. So let us see whether it is actually a heap. So actually max heap. So I have taken a max heap as the example over here, and this 95, see this 95 is greater than all the other values in the children nodes, in the child nodes. See this 87, 92 all are less than 95, 68, 78, 92, 84, 55 all are less than 95. So as far as the 95 node is concerned, we can see that it is a max heap as max heap. So for 87 we have to see that the definition is can hold good as well. So this 87 has 3 children. Let us see, 68, 78, 55 all are less than 87. So with respect to 87 it is a max heap. With respect to 92, let us consider 92, 84. See, this one value is equal to 92 and one value is less than 92. So 92 is for 92 to be considered to be the node n. This is a max heap as well. So for 68 we will see this 68 has a child which is a left child 55, and it has a value which is less than the value of 68. So as the 68 is concerned, as far as 68 is concerned, it is a max heap. 78 has no children, so it can be considered to be a part of the max heap. 92 and 84 also have similar considerations, that is they have no children, so these can be considered to be part of the heap as well, because they will easily hold on to the conditions of for the max heap. So in this example we are going to insert one value into the heap. Suppose we are going to insert some value into the heap so as to show you how the insertion process takes place over here. Suppose we are, for insertion process, suppose we are going to insert anything like, suppose we are going to insert anything like say about 90. So insert 90. So let us take that 90 is to be inserted into this max heap. So what happens in case of 90 when we try to insert it? In this case, before insertion, I will consider this heap to be arranged, this elements of this heap to be arranged in a linear array, linear one-dimensional array in this manner. Suppose this, see this. How many elements are there? Let us calculate. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 elements in this question. So we will consider an array like this: 4, 5, 6, 7, 8, 9, 10, like this. Suppose this is an array: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. So this is an array, and we will put these values one by one into an array in this order, that is top down, left to right, top down, left to right, top down, left to right. So what is top down, left to right? That is, we will consider this 95 to be placed over here, we will consider this 87 over here, we will consider this 92 over here, then we will consider 68 over here, then we consider 78 over here, then 92, then 84, then 55. So this is the representation of this max heap with respect to in the way of a one-dimensional array. So in this way, by top-down, left-right fashion, we will populate this array. Suppose the array name is A, and this we are populating the array A in this top-down, left-to-right manner. Now, what is to be done? If we are going to insert any value like 90 or any other value, we will first consider it to be populating the array in this fashion. That is, what is the first vacant position in this array? Which is the first vacant position which is found in this array? This is the number 8 index position is the first vacant position in the array. So that is to be filled up by the value which is to be inserted into the existent heap. So this 90 should be considered over here. So the position of this number 8 index on this heap is nothing but, if we draw that, we will have a heap like this: 95, 87, this is 92, sorry, this is 92, this is 68, this is 78, this is 55, this is 92, this is 84. So far it is very equal to this heap which we have drawn there, and after inserting 90 into the number 8 index position, so 90 will be linked in this manner. Suppose 90 will be linked in this manner. So what is the position of 8? This is 0, this is 1, 2, 3, 4, 5, 6, 7, and this is the position 8. So the right child of 68 will have a value of 90. But if we see that this 90 is inserted on the right subtree, or the right child, as the right child of the heap rather, of this 68, then we see that it violates the principle of the max heap, because max heap will have some value in each of the node of max heap. If considered to be, the node is considered to be n, they will have values which can be equal to or greater than the child nodes. So if we consider up to this 60, up to this 87, 92, we can consider 78, 92, 84 as well. All are holding on to the conditions of max heap. But for this 68, we see that this 55 is less than 68, that is good, but this 90 is greater than 68. So this 90 placed in this position will violate the very basic feature of the max heap, or violate the very basic definition of the max heap. So in order to reheap, that is, reheap is nothing but procedure of arranging the heap data structure after the insertion process has been done, and when the value when we see that it violates the condition of heap, we have to make necessary arrangements to accommodate this 90 on any part of the heap, so as to make the heap look like a perfect heap, that is, it obeys all the conditions, or obeys the definition of the max heap, or definition of a heap. So if this 90 is now situated over here, it violates the condition of the max heap, because 90 is greater than 68, which should not be placed in this heap, because it is a max heap. So what to do in that case? We have to make some operations, like I will show you the operations. I will just try to compare this 90 with its parent. So 90 is to be compared to its parent, and see, 90 is greater than 68. If we see that this 90 is greater than its parent, then we will swap these two values. So if we swap this 90 and 68, and after swapping, 68 will come over here and 90 will go over here. So that will reheap this part, because 90 over here and 55 and 68 over here will definitely be giving you a max heap. But if we see that 90 is over here and see 87 is over here, we see that still 87 is less than the value of its child node 90. So that also needs some modification in order to reheap the heap. So in order to see what is to be done, we see first this swapping takes place. 90 goes here, 68 comes here, 90 goes here. Then we have to compare this 90 with its parent. Its parent is 87. So 87 is, since 87 is less than 90, we have to swap this 90 to this position and 87 will come to this position. So after doing that, we will again try to compare this 90 with its parent. So 90 should be compared with 95 and see that 90 is less than 95. So 90 will remain over here and the reheaping procedure is done with now. So if we just reheap, we will see that what happens. 95 remains over here, 90 comes over here, 90 comes over here, like this, like the way I have described. 90 will come over here, 87 will go over here, 68 comes over here, 55 remains over here, and this portion 78 will be over here, 92 will remain as it is, 92 will remain as it is, 84 will remain as it is. So now suppose if we see that 95 is greater than all the child node values, 90 greater than all the child node values, 92 greater than or equal to all the child node values, 87 greater than 55 and 68, well and good. 78 leaf node, 78 is nothing, has got no children, so this can be considered to be a part of the heap, and the similar considerations can be considered for 92 and 84 as well. So we can see that this is a perfect max heap after the insertion of 90. So the position of 90 is, if we write the array once again, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, like this. So 95 is now 0th element, 90 is on number 1, 92 over here, 87 over here, 78 over here, 92 over here, 84 over here, and 55 over here, and 68 in the 8th index position. So this, see, we have increased the array size by unity because we have inserted one more element into the existing heap data structure, which was a max heap in our example. So after inserting 90 in the first instance, we will easily insert the 90 on the first vacant position, but that vacant position means we need to reheap the heap after insertion of the 90 in the first vacant position in this array in this manner, which we have followed in this particular example. So after reheaping, the heap becomes like this. It is a perfect max heap. So this is our solution. After the insertion process, 90 goes to its proper place and the reheaping is done, and the array looks like this. See, this 90 has been shifted to the position of number 1 index position, and number 187 has moved to the number 3 position, and so on and so forth. Some changes have happened in the array from this array to this array. So this array A becomes like this. So if you have any doubts and queries relating to this entire example of insertion into a max heap or an insertion into a heap, you can well post your doubts and queries into the comment section below so that I can address them. Thanks for watching this video.